All right, let's go ahead and have a seat and we can get started. So thanks everyone for coming. We are going to record this presentation today so that we'll have it available in the future for folks that may be with us to join us. And our goal today is to talk a little bit about FIRST Robotics, and to with the end goal is that we would like to encourage and figure out how to get more teams and more high schools in New Mexico participating in FIRST Robotics and thinking about FIRST Robotics. So we're going to talk a little bit about that today. If you want to go ahead and bring up the agenda. So my name is Andy Erickson. I'm one of the mentors for Project Y in Los Alamos, which is Team 4153. And we'll have a couple other people speaking today. And then at the end, if we have a little bit of time, we wanted to show you our robot from this year and maybe do a little bit of a demonstration. We also have a different kind of robot called the FIRST Tech Challenge robot, and we'll talk a little bit about that program today as well. So we're going to go through just kind of a bit of an introduction on FIRST Robotics. We're going to talk about how to start a team, and you know, one of the key messages we'd like anybody who's thinking about starting a team would be that the cost of registration, there's many grant opportunities out there. The cost shouldn't be the thing that's holding you back for starting a team. Gracious professionalism, we'll talk a little bit about why we think FIRST Robotics is unique when it comes to robotics and STEM, after-school STEM activities. Talk a little bit about what we can do in New Mexico to network and help encourage teams in more remote locations to get the scientific, the STEM education that they're interested in. And then finally, we're going to talk about FIRST Tech Challenge, which is another part of the FIRST family of robotics. So with that, I want to introduce Amanda Kittrell, who is the CEO for Project Y this year coming in, and she's going to lead us on a little bit of a discussion about FIRST Robotics and what it is and what it means. So with that, I'll turn it over to you, Amanda. Sasha?
Hello, my name is Amanda Kittrell. I am currently the CEO of Project Y.
I'm Sasha Vineyard, and I will be the CAD master of Project Y this year.
Yes, so first we'd like to start off with what is FIRST. So FIRST itself is an acronym. It stands for Inspiration and Recognition in Science and Technology. It is a global organization that encourages and involves STEAM. And we do this through a series of programs that run from like K through 12. So we've got FIRST LEGO League, FIRST Tech Challenge, and FIRST Robotics competition, which is what we do. And then after students have graduated, there are millions of dollars worth of scholarships that are provided for those students after they leave through the program. All right, so what is FRC? FRC stands for FIRST Robotics Competition, which again is what we do. We historically have been given 6 weeks to build and design and program a robot from scratch. And we are part of the Texas district, which is FIRST in Texas, which is New Mexico teams and Texas teams. And we are the most advanced program at FIRST because we are kind of that top mark there, which is only high school. And we think it's the cornerstone to building a more diverse and involved program across your community. So can you play any of the videos? So we'd like to show you a little bit of a clip of what we do. This is one of our videos from
drivers
one of
behind the line.
We were really proud of.
3, 2, 1, go!
5 versus 4. We got shots fired already from both sides. Purple Haze nearly missing. Dragonflies with 1 for the Blue Lions. And Timberwolves barely
We'd like
missed
to point out
those
that our
shots.
robot is right here.
Yeah, so our robot is the one with the
Going
big
into
lines
color
on it.
operated in
And
favor
this
of
was one of
the
our
Red
quarter finals
Lions.
from this competition.
Dragonflies with 1
And
cargo.
we
They might be
ended
looking
up
to
being
score.
captains,
Timberwolves with a
which
score
we'll
to the
explain
lower
later.
hub.
But pretty much we
And
worked with 2
another
other
one.
teams in order to
Yes, from the
compete
Timberwolves.
to the best
Barely
that we can.
missed. 2 shots for the Red Alliance. Project Y going to get some cargo right now. Not much defense being played. Both teams just trying to score as many points as possible. The Wolves barely missed that, shooting a little bit too far. Their alliance partners, the Tigers, getting one to the lower hub.
So another team that's
77-50
pretty significant in this is
playing
75-40.
ball wrangling
Their
a little
team
bit, trying to
from
play defense to help their Red Alliance.
the
The Tigers
Albuquerque,
with one
Zambia area.
cargo. They're trying to go
And
score. Timberwolves
Another
with the score to the top
friendly New
hub.
Mexico team.
And no, so close. It pops out at the last moment.
So that's just like, again, a short clip from this year of what we do. Just kind of give you a basic idea, but we'll go over it more later.
So how our season works is, as we have said many times, we are team 4153. We are in Los Alamos. FRC is between ages 14 to 18. We have about 2 months to build a robot from scratch, which includes programming, building all the parts, machining the parts we need, so that we have a working robot when we go to competition. There are thousands of teams worldwide, and as we have talked about going to Worlds, we get to see a small portion of those thousands of teams.
So I'll keep over here. Hi, my name is Minta Tun. I am the outreach lead for Point.
If I could ask you to really use your outdoor voice.
Okay, yeah. So hi, my name is Minta Tun. I am the outreach lead for Team 4153 Project Y. So right now we're gonna go over just how this season went for us. So basically this year our game started on January 8th. That was when FIRST announced the challenge. The game this year was called Rapid React, which we'll get into the details of a bit later. Then we had 10 weeks to build, design, and code the robot before competition. So the general process of how this works is we brainstorm ideas, we design it, we build it, we code it, we tweak it, we compete, and then do it all over again. Basically, we did that about like too many times to count. Went through about at least a dozen iterations on each part before we put it on the final robot and took it to competition. So next we will be talking about the game.
So pretty much this year I happen to be the drive coach as well. And so pretty much I worked with my strategy team in order to come up with strategies to win this year's game. If we want to show the game. So basically we're given 2.5 minutes to compete per game, and then we've got about 12 matches for competition.
I think we should explore a few.
And it's like I mentioned, we worked in the quarterfinals with 2 other teams. So that is what we call an alliance. There's the red and blue alliances. And it's pretty much a randomized face-off against each other until you get into playoffs. So now we're going to show you what we were given on January 8th to come up with our game.
Here's game Rapid React, presented by the Boeing Company. 2 alliances of 3 teams each compete to score their cargo balls into the lower hub and the upper hub. They earn additional points if the robots traverse the rungs of their hangar. Robots start each match on one of their tarmacs and may be preloaded with 1 cargo each. During the first 15 seconds, robots are autonomous. Without guidance from drivers, they leave their tarmac, score preloaded cargo, and collect and score additional cargo. During the remaining 2 minutes and 15 seconds, drivers control their robots. They continue to gather up 2 cargo at a time and score cargo in the lower and upper hubs. Cargo scored into either hub count towards the cargo bonus. Launch pads protect robots from contact by opponent robots. Robots may use either terminal, where their human players assist the robots with acquiring cargo. As time runs out, robots race to their hangar and traverse as many rungs as possible. The higher a robot gets, the more points it earns. An alliance that reaches a hangar point threshold is rewarded with a ranking point. The alliance that earns the most points wins the match.
Okay, so like like the video mentioned, there's 3 different periods: the autonomous period, where we're not allowed to touch the robot at all; the teleoperated period, which is where we drive the robot; and then the end game, which is at the end of teleoperated, which is pretty much where we do the monkey bar challenge. And this year, like the video said, all we had to do was shoot balls and climb, which seems pretty simple, but it can get really, really difficult. And score as many points as possible to basically rank ourselves throughout the competition, and thus throughout like the district that we're in, so that then we compete in worlds.
So next up, we're just gonna have a bit of fun and just like say, what would you guys do for this challenge? Let's assume you had infinite money and infinite labor. What are your ideas for this challenge?
It's pretty much just like an open brainstorm to just kind of get you thinking how we have to think at the beginning of the year, as we are given just that one video and then a set of rules and pretty much nothing else. It's all our imagination. So like this year, there were some teams who came up with crazy ideas, like a robot that could jump, and then
Yeah. So we saw jumping robots, robots with like turrets, swerve drives, all sorts of things. So basically, sky's the limit. Think of ideas. Just say it out loud if you come up with something. So, for example, basically, if you look at our robot, we use a multiple wheel shooting system and a climbing system based on hooks.
yeah. So we would like to show you our a video of our robot reveal, which is pretty much something a lot of teams do, where they take a really nice video of their robot just to show it off, and pretty much show everyone else what their robot is capable of. Because we do watch these in order to kind of scope out the competition, yes, but to also see like who we can work with, and also to get new ideas for next season and so on. So this year, our robot was named Ursula, which comes from yeah. So it comes from the Greek letter Y because we have five. So this year we designed our robot with a swerve drive, which is pretty much a drive that can turn while moving, and it's quite a fast drive.
Not really.
All right, so this is a show of our intake where we take in the balls, and then it moves through basically a system that will move it straight to the shooter, so that it can shoot that like basketball hoop looking thing. And then here's our climb. We were really proud of this because it was able to go to the top of the monkey bars in a very short amount of time.
It can traverse in the robot.
So basically, you can get the top points.
Yeah, that's a cute little crank right there. You can't see it too well from that angle. But that's what a bunch of other teams came up to us and talked, like, asked us about, and why we came up with that kind of design. And they thought it was really cool to do. And we did it because we really thought that we were really, really worried about having that little latch that just flips back up and hooks on would either have it fall off easily or we wouldn't be able to get it back off. So pretty easy solution. We don't have the little.
All right, so we kind of mentioned the competition earlier, and we mentioned that we're part of the First in Texas district, which the way it's run is there's district events, then there's district championships, which is basically the equivalent of a state, and then there's world championships. And so at each of these events, there's qualification matches, which goes into alliance selection, which is where you pick the teams that you work with, and then it goes into playoffs. This year, we were captains in Fort Worth and Amarillo, which means that we got to choose who we worked with for playoffs. And then at Fort Worth, we won the Gracious Professionalism Award, which we'll talk about later, GP. And then we also won the Engineering Inspiration Award at both Amarillo and the district championships. And then once we went to Worlds, we worked with our alliance to win the Carver division, which basically means that we moved on from the I guess, playoffs of Worlds into the top 6 teams or
The top-
6
Yeah, the top 16, top 6 alliances in the world,
alliances. Yeah.
made up of the top, let's see, 4 times 6, that's 24 teams. So
Yes.
yeah, we, against those 6 out of those 6 alliances, we ended up coming in 4th. And yeah, 4th place out of the world. I don't think that's all too bad. 3,800 teams. That's not bad at all.
So this is another one of our competition videos. And this is from the district championship.
And in quarterfinals number 7, Red Alliance is quick
So
to
again,
get Cargo in the upper
We're
half.
with the Ys.
Red Alliance with 2, Blue Alliance with 1, 2. Cargo of their own. Lead is quickly building 18 to 14 as the drivers take control over the
And we're
robots
really
to
proud
grab
of this
cargo
because,
and to
the
continue
way
to
it works
move
is it's
on.
pretty much a face-off
Red
between,
Alliance is
or
looking to hold
within
on to their
the top
1-win
ranked
lead.
alliances.
Blue Alliance is
So we
looking to
happen to be
upset
ranked
them
7th, and then what we were
decent
competing
job,
against
but
was the
now with
second alliance,
24
which
to
is pretty
18,
good.
can they hold on to the
But
lead?
here,
They're gonna need to
our
get some
alliance
more
worked
cargo
really well
up in
together.
there.
And what you don't see is there's a lot of communication behind
Blue
the
Alliance
scenes
is
where you're
shooting,
working
but
with
the
those
cargo's
other
going
teams
straight
in
in the
order to
air,
come up
not
with
quite
a
where it needs to
very
be.
strong strategy to try and win,
Bouncing cargo
or
out
at
of the
least to
net,
try
Red
and prevent the
Alliance
other side
shooting
from
way
winning.
long.
And so here we play defense
Right
against
now, Red Alliance shoots 1,
some of the
shoots 2,
top
but
teams
only
out there.
gets
So,
1.
for example, for each of those 6 up there, and I believe in Texas there was one. There was a stat for this, number 5. Was it Texas or not? I think it was Texas. Yeah, their 5th best shooter in Texas, 2468, is another team that consistently goes to Worlds, and I think they almost always get chairman because of their program. Yeah. Also, Amanda was being humble on the whole, working together thing. She really, her and Sasha, and our pipeline, yeah, they came up with like great strategies. They're really the reason why we had as much success as we did. So yeah, and people actually listen to them.
Yeah,
It was great. Like they had power.
And so really, like I said, there's a lot going behind the glass, as we say, where there's a lot of screaming going on, but it's screaming, trying to make sure that everyone knows what's going on. So it teaches a lot of really great communication skills.
So part of my job during the season, after, so during our first district match in Fort Worth, I worked as our safety captain, so I made sure our field was safe, and I ended up getting the safety award for the first day. However, during Amarillo and both of the Houston games, I was the lead strategist. So my job was to work with a small team of individuals to look at all of the statistics of each robot and see the best way to work with those teams, and to also, in some sense, a lot of times lose the best. So what losing the best meant was it was very important to get what are called ranking points, because this helps you rank over time. So you have to prep your team, and that was part of Amanda's job, to know that some games you are going to lose. However, how can you lose the best? That was my job.
Right. And so why we're so proud of this is, yeah.
Okay.
So why we're so proud of this is we worked with our alliance, like I said, really well. And despite being pretty much the underdog in this, as you'll see here in a second, we ended up winning this match that we thought was almost impossible to win. And it was truly, a great feat by the teams that we worked with.
It involved, Evan had said, communication in the background and working with the team so that we could each find each of our strategies so that we could win. And our proudest moment was 4206. They're the team from Fort Worth who ranked about 5th in Texas. We were very proud. They had actually come up to us and told us we were the only team that had taken them down as many times as we did, due to our ability to look at their strengths and weaknesses to see how we could take them down.
And despite this, this is something that we'll talk about a little bit later, but despite this, and despite going against so many people all the time, we're still like a very strong community, and we don't tolerate like bad sportsmanship. So even though you know, we ended up beating them a few times, like Sasha said, they would come up and compliment us, and of course we would go to them, and like they're one of our favorite teams. And so you form a lot of friendships between teams that some days you'll be competing with, and other days you'll be competing against.
I believe that they also did at one point come up and help us, and during Worlds, they were not able to go further in their division, so they came to our stands and decided to cheer for us.
Oh, yeah.
Okay, so now we're gonna hand this off.
I'd like to pause for just a moment before I introduce Chris Forsyth and see if there's any questions. Alexis, if you have any questions or any questions for the folks participating online, and you can either just throw your question out there, or put it in the chat if you're online.
Not yet.
Okay, yeah, totally fine. I don't want to put you on the spot. Any questions for those online that are participating? Okay, great. So I'd like to introduce Chris Forsyth. Chris is the coach for the Manzano Monarchs team and was a rookie team last year. And he's going to talk to you a little bit about what it takes to start a first team and what some of the opportunities are. So Chris, I'll let you take it away.
So where should I stand for the camera?
That black piece of tape is the edge.
Yeah, that's
Black piece of paper.
That's
Excellent. Okay. Well, that's a great summary of FRC. I mean, that was really good. Okay, so as Andy mentioned, I'm the coach of the Manzano Monarchs, and actually we started up the year of COVID. So that was a year there were not actual in-person competitions. So last season we were a rookie team with regard to competitions. So we went to our first and only tournament this last season. So I'm going to talk about 5 topics: the cost, registration, administrative aspects of starting a team, the personnel in terms of the people that you'll need to pull in for your team, the infrastructure that you'll want to have in place, and then just some general ideas on strategy for starting a team. So next slide, please. Okay, the cost. A lot of people, and I've heard this said from other people in robotics programs, look at the cost, $6,000 registration fee just to get in the game, and see that as prohibitive, that's just way too much money. But the reality is there are grants out there that your team, starting a new team, you should not have to pay a penny for registration. The Department of Defense DoD STEM program offers grants for rookie teams that will essentially pay the entirety of the registration cost. FIRST, the overarching program that we're part of, they offer grants for rookie teams. NASA offers grants for rookie teams. If you have anyone on your team that's a former employee or a current employee of Boeing, they offer grants. Our team, like I say, we're entering our 3rd year this coming season. We've never had to pay a penny for registration costs. So even though $6K sounds like a lot of money, you should be able to get a grant to cover that. And if you are a team in New Mexico, this coming season, I have a grant from the RBC Foundation. If you are not able, if you are starting a FRC team this coming season, and you cannot get one of these other sources of funding to pay your registration fee, I can pay your registration fee. So any team that wants to start out a new team this coming season, and you can't get funds otherwise, you're not going to need to pay a registration fee. We'll give you the money for your registration fee. And I will caveat that by saying I can do that this season, but I cannot do that. I cannot promise I'll be able to do it next season. So with regard to the registration cost, that covers your registration as an FRC team. Along with that, you get a kit of parts, which essentially has everything you need to build a robot base, including the electronics and even including a drive computer. So you'll be able to build the base of the robot, and granted, you'll want to, actually, you could go to competition with just a robot base and play defense. And that would be sufficient. That would be noteworthy for a rookie team. But anything you want to add to the base, then the team would have to come up with the funds to pay for that. But at the very least, you get everything you need to build a robot that you could take to a tournament. And if all you want to do is play defense, you could do that. And then likewise, it includes the registration fee to go to one tournament. Most teams will go to multiple tournaments. So the additional tournaments, you would need to pay the registration fee for those tournaments, but your registration fee for your team covers one tournament. And then the other costs that you would then need to cover, and I like to emphasize, running an FRC team is as expensive as you want it to be. If you are a school or a organization that doesn't have a lot of money, you can't do this for nothing, but you can do it for almost nothing if you really want to pinch pennies and save money everywhere you can. On the other hand, you have established, experienced teams that will spend thousands of dollars. Just so you know that it's not an unfair playing field. If anyone knows the exact, fill me in here, but I know in the game manual, there's a limit on how much you can spend on your robot. And part of the tournament competition is you have to submit a bill of materials that is everything that went into building your robot to demonstrate that you have not exceeded the maximum amount of money you're allowed to spend on your robot. Used to be 5,000? Okay, so yeah, so there is a limit on how much you can spend, but like I say, you can do it if you really want to pinch pennies, you can do it for almost zero. And the other costs include materials to build anything that you add onto the robot base. You can buy a lot of expensive mechanisms and electronics and so forth, or you can improvise. And essentially, I'll give you an example of, we were working with, this was not FRC, but this was a program below FTC, which I believe Madeline's going to tell you about later. We were working with an FTC team in Raton, New Mexico, and they had absolutely no money. In fact, we actually gave them the money from a grant to buy the basic robot kit. And essentially what they did was they went to their local hardware store and they donated the materials to do, essentially to build out their robot. So if materials, again, you can spend as much or as little as need be. Also, you need to think about the travel to the tournaments. And generally, if you're in New Mexico, you're probably going to be competing in Amarillo. They have other tournaments around Texas. I don't know if El Paso's, I've heard a rumor El Paso may be coming back, but so you will be traveling out of state for a tournament at least this next season. We are working to try and get a tournament here in Albuquerque, but that will definitely not happen this coming season. So for the next season would have to be taking your team to Texas for a tournament. And then other costs are just accessories like team t-shirts, banners, things that you put in your pit at the tournament, any swag that you hand out at the tournament and so forth. Next slide, please. So registration and administrative. So this is really for the coach of a prospective team. There's certain administrative things that you have to do to register a team. And They are not excessive, but they do take time, and it is something that you have to attend to. First off, it starts with just registering your team with First Inspires. Once you've registered, at some point in the season, you need to select your tournaments and sign up for the tournament or tournaments that you plan to take your team to. Each member of your team, as well as each of your mentors, needs to register with the First Inspire program. And here, for any students on the team under 18 years of age, their parents have to be involved in that process. So it's a matter of engaging with the parents of the students to get them to go online to the FIRST website. Sometimes you may be sort of walking them through what to do. And actually, a really good mechanism for doing this is to have a team meeting where you have the parents come, have 2 or 3 computers set up, and you as coach or your mentors help the parents go through the process of registering their student for the team. And then there's the youth protection program that the coach and all the mentors go through. And this is administered, actually it's not administered by FIRST, they contract with another company. And my understanding, I've never had to pay for my background check, but your coach and your mentors, all the adults, have to go through the youth protection background check. And once again, my understanding, I know I've never paid for it, and I don't think there's a scenario where you actually do have to pay for getting that background check. Next slide, please. Okay, so the personnel that you're going to need for your team is you need a coach. The coach, and this may sound kind of funny because you might think I could not possibly coach a robotics team because I've never done any type of mechanical or electrical work or done anything with robots. Absolutely not true. The coach, there is no technical expertise necessary. It helps to have some technical expertise, but it is absolutely not necessary because my philosophy and the way I view being a coach, your job as coach of the team is to clear the way so your students and mentors can get work done. So that as coach, think of yourself, you'd be thinking of yourself as like the CEO of a small engineering firm. You go to one of the local engineering firms here, their CEO, very rarely do they do technical work. Their job is to enable everybody at the firm to do and to get technical work done. And that's kind of the way I see the coach of an FRC team being. It does help if you got technical expertise, but it is not essential. And I say this because the message behind what I'm trying to say here is, let's say you are a geography teacher, or I don't know if they teach geography, I don't know if they have geography classes anymore. Let's say you are I'll pull one out of the air, a Spanish teacher. And you just have an interest in robotics. You've never built a robot or done any programming. You could still be a coach, and you could actually be a very effective coach. Mentors. Ideally, the mentors are an essential part of your team. The mentors really are, really make or break the team. Ideally, you want someone who's had FIRST Robotics competition experience. We are extremely lucky because we have one of our mentors, he had mentored with FIRST Robotics competition teams in the past. He has the expertise. He could build a robot from scratch by himself, and so we were extremely lucky. So ideally, you'd like to have someone with FIRST Robotics competition experience. However, I know those people are not plentiful in New Mexico, and FIRST Inspires, the overarching program, they have a network set up where they will help you find and locate a mentor or mentors from other parts of the country who you can work with remotely, so that you can get that individual engaged on your team. They may be sitting in Columbus, Ohio, but they will be available to you as a mentor and can work with you remotely to help your team along. What you do need to have locally, though, is you need a mechanical mentor. So this is someone who understands how to cut metal, how to drill, or essentially knows how to work with metal parts and mechanisms. And it's kind of nice if you have a mechanical engineer who's had a lot of hands-on experience with various mechanisms. But if you have someone who's a machinist, works in a machine shop, you're going to be a great mentor. Even someone who's an auto mechanic. If you have someone who has the knowledge and expertise to take an automobile engine apart and put it back together, they are going to be a fantastic mechanical mentor for your team. So it doesn't have to be an engineer. It could be anybody who has mechanical expertise and knowledge. Likewise, you need someone who will serve as your electronics or software mentor. So this is someone who understands how to do basic wiring, understands generally with these robots, they have LabVIEW, which is a commercial product that you can use to program your robot. You can also program in a C-based software language called Robot C and Java, correct? And Java. So if you have someone with some basic software skills who can do some basic wiring, they're going to be able to serve as a mentor. So for instance, if you don't have access to someone who's an engineer, if you have someone who's just a hobbyist or tinkerer and likes to do things like build speakers or things of that nature, you've got your electronic software mentor. And the thing I like to emphasize with the mentors is with a lot of these robotics programs, the idea is the students do all the work, the mentors are at arm's length and really want to make sure the students do all the work and solve all the problems and everything. And I know a lot of teams do operate that way. But one of the things that has always attracted me to FIRST Robotics competition is with FIRST Robotics competition, it's okay if the mentor rolls up their sleeves and gets their hands dirty. We regularly, when you come in and see our team when we're working, regularly you'll see a mentor with one or two students, and they're all there, hands on the tools, turning, wrenches, or whatever. What I like to emphasize is you want to have, I believe, and this is my opinion, you want to have a mentor who's happy to roll up their sleeves and gets their hands dirty. But ideally, what you want that mentor to be doing is someone who enjoys problem solving, but equally and more importantly, enjoys teaching students how to solve problems. That's really the role of the mentor, is the mentor is teaching the students how to solve problems. And then your student team members, I would say generally you want to have 6 to 8, and I refer to them as solids. And when I say a solid, I mean, you want to have, say, at least 6, 5, you're probably going to be okay, or maybe even okay. But by solid, I mean a student who's really engaged, who's going to be there for every meeting they can possibly make, and is going to be putting forth as much effort as possible. However, though, one thing you do need to keep in mind is your student to mentor ratio. And I recommend a student to mentor ratio of somewhere between 2 students per mentor to 3 students per mentor. Because one of the things I've observed is you have FIRST Robotics competition teams with as many as 50 students or more on the team. And when you get too many students per the number of mentors you have, the students just don't get as much value out of the program. And I think one of the greatest values the student gets is that one-on-one working relationship with a knowledgeable adult. That they get to know that adult, they build a working relationship with that adult. That adult becomes someone that they can put down as a reference when they're doing job applications. That adult becomes someone who's going to help them find a job, help them find an internship, who's going to do, these things that are going to go beyond FIRST Robotics competition and help the student get on their feet in terms of getting their career, wherever it is, whether it be going to college, going to community college, or going directly into the workforce. Someone who is going to be there that's going to give them the foundation they need, and in many cases actually take steps to help them, whether it be writing a letter of recommendation or so forth. Next slide, please. Infrastructure. You need a meeting space. So this is a place to meet and store your robots, your supplies, your tools. It's not necessary to have a dedicated space, but doing programs of this nature for over a dozen years now, it makes a big difference having a dedicated space. It is really, really helpful if you own the space, as opposed to having a space that you're sharing with other people, which means that you've got their stuff to be aware of and so forth. You need a basic mechanics tool set. So if you go to Home Depot or Lowe's or go on Amazon and buy a basic, you can, tool, like for instance, 267, I don't know why that number popped in my head, piece mechanics tool set. Something you can get for probably about $50, $60. You need a basic mechanics tool set. However, one thing I recommend is, let's say you go and you buy that 267 piece mechanics tool set. Out of those 267 pieces, you're probably going to use between 15 and 20. Most of them, one of the things I've learned, if it's a tool that they're never going to use, just take it, put it in a box, get it out of the way. And then figure out what are those 10, 15 or so tools that you're going to use and use over and over and over again. Generally, it's a certain size socket, it's a certain size wrench, get multiple copies. Because I find that is just so beneficial. If it's a certain size socket you need, you've got 5 or 6 copies of it. So no one ever has to waste time looking for a tool. One of the things that I harp on with our team all the time is time looking for tools is lost time. You should never have to spend time looking for tools, or likewise, you should never spend time waiting for someone to finish because you need the tool that they're using. In terms of equipment, and I've tried to rank these in sort of the approximate order of importance, you're definitely going to need hand drills. And I recommend multiple hand drills. And one of the lessons learned we had was you want AC powered. You want the drills that you plug into the wall, because oftentimes the battery powered drills do not have the power to do what you need to do. So I generally recommend, like our team, we have 2 drills. And when we're in the heat of our build season, both of those drills are almost constantly in use. A drill press. And with the drill press, I also recommend multiple sets of bits, because you will break bits. And so consequently, I would say a drill press with 2, ideally at least 3 sets of drill bits. And actually, I found on Amazon where you can go in and for about, I think it's like about $45, I got a set of drill bits where for the common sizes, the ones that break all the time, it has like about 10 or so. And then for the sizes that you almost never use, it only has 1 or 2. So multiple sets of drill bits, a power miter saw, or some people call them chop saws, with a metal cutting blade. is very beneficial. However, in a pinch, if you're pinching pennies, you can cut with a hacksaw. And I've cut plenty of parts with a hacksaw. A vise, a well-mounted vise will get a lot of use. If you're really totally in a pinch, you can get by with clamps. You're going to need a battery charger because you're going to be using 12-volt DC batteries. A bandsaw with a metal cutting blade is nice, not necessary, but it is nice. A grinder, although if you don't have a grinder, hand files. Well, you can get by with hand files. Other equipment that is useful, and you notice I have in all caps, absolutely not necessary, but useful. Some type of computer-aided design package so that you can do computer 3D models of your parts. Again, not necessary, but it is nice and it's good skills. 3D printer, welder, CNC maybe machine, laser cutter, mill, lathe, electric riveters. We use a lot of rivets. We do use rivets to attach a lot of our parts, and I think one of the best purchases I've made is a handheld electric riveter. And of the absolutely not necessary, I would say the riveter would be at the top of my list in terms of useful equipment. Next slide. And finally, strategy. First off, know the game. And this is both from the perspective of the coach as well as the team members, that at the beginning of the season, read and study the game manual. It's a big document, but to really go through it, annotate it, make notes, make sure you understand the game, at the deepest level, so that you understand what the rules are, what the restrictions are, what you can do, what you can't do, and so forth. And then this also means following the game during the season, because a lot of times when they first release the game, there will be restrictions that, there will be, let me put it like this, it will say you need to do this or you need to do that, but it will not be in detail. And then as the season progresses, people will ask questions and they will specify more detail associated with the game rules. So read, study the game manual. Watch most of the FRC tournaments are streamed, actually streamed live. Very, very useful to watch those early matches, to see what other teams are doing, to see the strategies, to understand where teams are having trouble, to understand that idea that you had for how to launch balls, other teams have tried that exact same idea and it's not working very well. So watch the early matches, study what other teams have done, look at the robot reveal videos that come out, because some of the teams will have a working robot within 2 or 3 weeks of the game. Study those for inspiration, for ideas, and so forth. Secondly, be prepared. Everything will be harder and take longer than you expect. Almost every single thing you do is going to be harder than it looks, and it's going to take longer than you expect. And I emphasize very heavily with our team, understand the trade-off between complexity and reliability. Especially if you're a rookie team, I recommend you don't try to do much. I know, when you get the students together and they start brainstorming, they're going to have all these brilliant ideas for how to do all sorts of different things. And as a coach, one of the things that you're going to need to do is to often scale them back, to often, help them understand, yes, that is a brilliant idea and it will work wonderfully, but this is why it's going to be really hard, and we probably may not have the resources, the time, or whatever to actually make it work and work reliably. I know, for instance, with our team, what we did our rookie season, we took a strategy that said, we're not going to do a lot, but what we do is going to work 100% of the time. And the one tournament that we went to, we were selected for by one of the best teams in Texas, actually one of the best teams in the world, to be on their final alliance. And the coach of that team said, one of the reasons we selected you is we understand you don't do much, but we watched your matches, and everything you did worked, and you never showed up to a match and your robot was not working. So that's why it's like, starting out, don't try to do too much, but try to make it work, and try to make it work reliably. And that will actually help you go a long way when you get to the tournament. Every year there's a team called the Robomelts, which is one of the best teams in the world, and they have a thing called the Everybot. And the Everybot is essentially the first weekend after the game is released, they get all their mentors together and they design and build a basic robot that will do a lot within the game, will be able to score a lot of points, will meet a lot of the opportunities that the game presents. And usually within a week of the game being released, they've released a video showing that robot, as well as the detail for how to build, design and build that robot. We fell into the trap of thinking, oh, the Everybot looks like a great idea. Let's just do that. Worst decision we made last season. Because the thing about it is, even though it's a very effective robot and you can build it for under $1,000, it is a lot harder to build than advertised. The team that does this, they have a full machine shop. They have very experienced mentors and machinists and so forth. And for a rookie team, it is just, it was too much for us to try and build the Everybot, just simply because every single week we were, something that looked simple, we were like 4, 5, 6 hours trying to solve some simple problem that I'm sure the Robonauts, they had it working within 10 or 15 minutes. And so the Everybot, it is a very, very good source of ideas, but I discourage any new team from doing the Everybot because it's much harder than advertised. Let students make key decisions. One of the things I emphasize with our team is the key decisions. Like, for instance, the design of your robot, your game strategy, these things of that nature. Let the students make the decisions. As a coach or mentor, your job, I will advise, is give them the tools to make good decisions. Teach them how to use a spreadsheet. Teach them how to do, just lay out the pros and cons. How to teach them how to analyze a problem and make a good decision, and then let them make all the decisions. So you don't make the decisions for them, but what you do is you insist that they do the analysis that will enable them to make a good decision. Be accommodating. The students that are going to want to do FRC, they are going to tend to have a lot of obligations going on in their lives. FRC likely will not be their #1 priority. It's great when it is, but a lot of these students and some of the best students you're going to get on your team, FRC will not be their #1 priority. As a coach, you need to be accommodating and understand that the students have other obligations and enable and support them in terms of fulfilling these other obligations. So like, for instance, a couple of our team members, came to me a couple of weeks ago and said, we won't be able to do any of the Saturday meetings, during the fall because we have marching band. Great. Great. I mean, that's fabulous. I'm glad you're doing marching band. Don't worry. It's not a problem. I want you to be, be doing these other things that are important to you. However, though, the thing I emphasize with our team is rewarding those students who put forth the most effort. So in other words, there are certain roles on the team that are higher status roles, and use the opportunity, having the higher status roles to reward the students who are really putting forth the most effort. So like, for instance, when it comes time to go to the tournament, I would say probably half your team is going to want to be a robot driver. And you may not I know a lot of teams, they do tryouts because they want to get the best possible person there at the controls. But my strategy has been, if that is a prized role on the team, I want it to go to the students who put forth the most effort. Because, I know if they put forth the effort, put into hours, coming to the meetings, building on the robot, giving up other opportunities to commit to the team, they're going to put that same level of effort into learning the roles that I give them. And so that's why I emphasize, like I say, reward those who put forth the most effort. Yeah, at the same time, try to be accommodating. And then the last one is, I very strongly believe that the knowledge and skills the students get from doing FIRST Robotics competition, they may never in their life use that knowledge and skills after FIRST Robotics competition. What you're teaching them is how to do work. You're teaching them how to do work, how to solve problems, how to be successful, no matter what they do. And whatever they choose to do, it may never involve anything they learned with regard to building, wiring, programming robots. But the skills they learn in terms of how to work will transfer over to almost anything that they do after FIRST Robotics competition. So at that point, I'm done talking. Does anybody have any questions or comments? I would welcome those. Otherwise, I'll turn it back over to Andy.
I think Nick joined us. Nick started a team last year with in Alamogordo. And Nick, if you had just a couple of thoughts you wanted to add.
Yeah, I'd love to. So hello, everyone. My name is Nick Brinegar. I am a recent graduate of Team 5613 Thunderdogs, and I've moved on to a mentoring role right now, but I'm still pretty active with my team. I've been part of FIRST for like 10 years and FRC specifically for about 5 years. So I'm going to relay kind of the main 2 points that I think is really important to understand as a mentor starting a team. And it's that really, or like from the way our team approaches this, is that the mentors have 2 jobs, is to make sure that the kids have the skill of acquiring skill and project management. And that's the 2 things the mentors have to teach the students. And if students can do those 2 things, they can write their own ticket in life, do whatever they want to do. So part of this is connecting with the wonderful community that is FIRST Robotics. So there's things like the New Mexico FRC Discord server, where like we're trying to start that and have the goal of that being a really active community and resource for any new teams where students can go ask questions. There's Chief Delphi, which is an online forum group worldwide. There's a lot of good resources on there. I came in a bit late, so I'm not sure what people have already said, but going to YouTube and looking at robot reveal videos is a really good source of inspiration. And there's also a network called Fun, which is First Updates Now, that does interviews with teams and asks them, how they strategize their season and the steps they took to build their robot. And that's been really helpful for me personally as a student. And so like the main point for me is just to keep in mind, the mentors don't build the robots, it's the students. And it's just the mentor's job to make sure that the students have the resources they need to be very successful in that. And it doesn't take, like, you don't have to be a mechanical engineer to be a FRC coach, although it is helpful. But there's plenty of resources out there in the community that can allow any new team to be very successful. So you can branch out. That was really my main point. It's like, that's just kind of what's been really, really important for Thunderdogs and the team we started, 8528 Astro Chimps. And they, our team in this past season got rookie all-star in one of our competitions. They got 3 awards. Well, I'm not sure what the other 2 were, but got rookie inspiration last year and did really well in the actual competition too.
Perfect. Thanks, Nick. Appreciate that input and another viewpoint talking, I think, again, reinforcing that there really are a lot of resources to help start a team from a mentor perspective, a lot of stuff that's available online. Everybody that we've talked to today is very interested in helping new teams in New Mexico start. And so, I don't think that should be a major constraint, because there really is a lot that we can do to help new teams that want to get started. With that, I'd like to turn it over to Sasha Vineyard. I'm sorry, question?
Hello. Actually, I teach grade 6 to 8 students. We have a teacher there who actually teaches a little bit of robotics. So
yeah,
for I see this pamphlet. So for middle schoolers,
yep,
they go to First Lego League.
First Tech Challenge, and Madeline's going to talk about that here in just a couple of minutes.
All right. Thank you.
So we'll jump into the First Tech Challenge, which I view the First Tech Challenge as kind of either a middle school program or junior varsity, if you're thinking about it at the high school level. Whereas the FRC program and kind of what we've been talking about a little bit is a more complex thing, and it's more like akin to the varsity level robotics. So hang on to your question. We'll get to you in just a minute.
Yes.
All right. So with that, Sasha, we'll turn it over to you and talk a little bit about the culture of FIRST.
So the culture of FIRST is very important because it supports students. There's a lot of students, many like us, where we don't tend to fit in. So the culture is very nice that it makes it like a sports game. It's very fun. There's new challenges that we get to think of and how we can do them. We get to meet many people, and Evan will talk on this in a little bit. And it's just really fun because our job or our goal in competitions is how can we have everyone compete, because it is only fun when everyone gets to compete. So when we went to Amarillo, we had a lot of our teammates helping out the fellow New Mexico teams and even some of the Texas teams that needed some help, just because we want everyone to play. So it's not always just about building a robot, it's also about the community. So our team, we like to do certain activities so that we're a strong team, and it's also fun to just be together and be a team so that you have someone to belong with. So now I'm going to turn it over to Evan.
Yeah, my personal favorite part of the robotics competition is meeting all the other people from all the other different teams, because they are our peers. Just they have the same interests as us. They're just different backgrounds. So it's really, really interesting to get to talk to them. And also some of the more engaging aspects of, well, fun too. The competitions is they'll be playing like songs the whole time. It's pretty fun. And at some point, I remember our team and every other team on the competition field, so all 6 of us, we all got up and started dancing to, I think it was Footloose. Oh yeah, Cupid Shuffle too. Cupid Shuffle, Cha-Cha, Cha-Cha Slide. I don't know. Cha-Cha Slide and Footloose. We all got up and danced to those. That was great. And yeah, I personally, I still maintain a bunch of the friendships I made with people on other teams. And it's just, it's, if nothing else, it's a great way of getting out, networking, meeting other people. And these are, well, nerds, like we are nerds. So but like, we're very likely to go far later in life. So if nothing else, networking to get further later in life, to have those contacts is really a great thing.
All right, so what do we really do? One of our favorite quotes from our founder is, "We don't use kids to build robots, we use robots to build kids." So really, FIRST in and of itself, as a whole, teaches us a lot of skills that still aren't taught in schools, that are really valuable for our lives. So while, you know, the robot is right in front of you, everything behind it is so, like, there's so much more to it. So a lot of the life skills that we learn are just leadership, teamwork, entrepreneurship, gracious professionalism, which is part of the culture, competition, which is also part of the FIRST culture, and then real world problem solving, as was mentioned before. And it's just a lot of stuff that without this experience, I personally don't think I would know, because I just wouldn't have gone through what we go through FIRST as a whole.
So as I've said earlier, you also learn technical skills. So when I started out, like halfway through last year, I started to learn CAD completely from scratch. However, as many of our seniors know, learning these skills like CAD or design, programming, video editing, machining, and manufacturing can help them for their future. So our seniors, a lot of them have started to work at the lab. This gives them opportunities to do CAD at the lab or to help different employees around the lab. This also isn't specifically to our lab. There are many places that are willing to do this for students.
The lab referring to Los Alamos National
Yes.
Laboratory.
Our lab in Los Alamos. There are other benefits for students. There are a lot of scholarships with this program. And as we know from now going to Worlds, you can also talk to many people who are there from NASA, Department of Energy, I believe, and Boeing, yes, thank you. And they show what you can do if you work for them, and it gives you a gateway to a really nice job that you can get in your future.
All right, so what can we do? So this is pretty much what our team has been working on for many years now. Right now, as we're doing today, we're working on doing a lot more workshops and mentoring for other teams. So today is the recorded virtual lesson as well as an in-person one, just so that we can work to pass on the skills that we've learned over many years to other teams who are maybe just starting up, or who just need someone who has a little bit more experience. As also mentioned earlier, there is a New Mexico Discord server for teams here that because we're really working on trying to unify New Mexico as a whole, because we understand how hard it can be to be kind of isolated within your own community. So what we're working on is, again, just trying to unify everyone here, so we can really help you compete to the best of your ability. We also have a lot of local community events. Vincent, do you want to talk about
Yeah, sure.
this?
So basically, within the Los Alamos community, we host events such as like robotics nights, and also occasionally we, in a more non-COVID year, we would host tournaments for lower levels. We've hosted FL tournaments. Have we ever hosted FTC? No, we haven't. So we've hosted FL tournaments in the past, and then basically we went into with our local municipal government schools. We also have events where we can go and show off our robots and get kids interested in STEM. One recent one, mid-July, was Science Fest, where it was exactly what it sounded like, where basically various organizations would show up and talk about what they do for science and engineering, science, technology, engineering, and math, and at a local park. And it was just pretty much just a big party. Then we've also go to parades where we would walk along with the robot, and then fire t-shirts into the crowd using said robot. And then we work with schools.
Yeah, and This bottom part here, we also mentioned earlier about trying to get an FRC competition in Albuquerque that would serve West Texas and New Mexico, because we do understand how difficult it can be to travel to Texas. And that's definitely a hurdle that needs to be overcome, but we're working towards that.
Yeah, that would be more like that is our ultimate goal that's our ultimate near-term goal, is basically getting a FIC competition in Albuquerque. That's the big goal.
And just in general, making FIRST as a whole more accessible to New Mexico.
So Chris already went over a good bit of this, but basically running a team is as expensive or as cheap as you want it to be. This is what it looks like for us. Basically, yeah, so this is like what on a normal team's budget would look. We're actually about like a medium sized team, right?
Although we do a good bit in our community.
Yeah.
Our travel is also a bit higher because,
Yeah.
you know, well, for a New Mexico team, that's about what it'll look like, but to most teams, our travel costs it.
Yeah.
All right, so why are we here? As I mentioned, we really want to expand who has access to these programs, because they're absolutely fantastic for students, but sometimes it can just be really hard to get to them. And so
how we want to do that is create public-private partnerships. Obviously, the biggest entity that can help with this is the school system and the state. Basically, we've already started talks with the school system and state, and we're hoping that eventually we can get the state to help us. But obviously, the state isn't just a big money machine. It isn't infinite. So we're also going to be working with private companies, local organizations, corporations, and nonprofit and NGOs to help teams succeed. For example, we might say we are working to create a grant program with the schools, but at the same time, we still have like numerous sponsors who help fund our programs.
And again, as part of expanding who has access to this, we are always very open to helping whoever needs help, because that is part of the FIRST ethos, and we truly believe that that's a huge part of just life in general, is not being like a bad sportsman or a bad team in general in terms of like sportsmanship. We truly believe that you know, whoever needs help, we're going to be there and do our best to do that. Okay, so how can we work together? We're trying to increase the number of teams in New Mexico. Currently it's sitting at about 9, but we would like to have it to 25 to 30 teams, which is quite ambitious, but that is what it takes to host an event, or that's how many teams generally attend an event. And also we are working to get NMAA recognized, which takes a lot more teams than we have right now. But if we were able to do that, that would garner a lot more support within New Mexico for FIRST as a sport. And then also currently we're holding the workshop event, and we plan to have many more as the years progress, in order to again increase the number of teams in New Mexico and have New Mexico united as a whole.
Is that it?
Yeah, so I think that's our presentation. Was there anything else you guys wanted to add before we transition to the First Tech Challenge conversation? Okay, great. Thank you, Amanda. Thank you, Mintet. Are there any questions from folks online? And then we'll go ahead and pull up the presentation and have Madeline's going to come up and talk to us a little bit about the First Tech Challenge. And so give us a minute while we transition. Madeline, you want to come on up? And I'll introduce Madeline here to talk to us about First Tech Challenge. So, Madeline.
All right.
Hi, my name is Madeline. I am a FIRST alumni. I've been doing FTC since I was 14, and I've even dabbled a little in FRC. I really love participating in the FIRST program, and today I'm going to talk to you a little bit about FTC. First, I'm going to talk a little bit about the FIRST statistics. So FIRST is a robotics community preparing young people for the future. So FIRST students are prepared for greater success in the classroom and workforce. Our programs use strategies known to increase student interest and engagement in science, technology, engineering, and math. These strategies include hands-on learning, working as a team on real-life problems, exposure to careers and adult mentors, emphasis on FIRST core values, and a celebration where students can showcase what they've created and learned. Findings show that FIRST students are more likely to continue and to show an interest in STEM. Now, FIRST students have positive outcomes in workforce skills, 90% in communication skills, 93 in conflict resolution skills, 95 in time management skills, and 94% in problem solving skills. Our first mission is to inspire young people to be science and technology leaders and innovators by engaging them in exciting mentor-based programs that build science, engineering, and technology skills, inspire innovation, and that foster well-rounded life capabilities, including self-confidence, communication, and leadership. Now on to the FIRST Tech Challenge itself. So the FIRST Tech Challenge offers students the opportunity to experience real-world project-based learning with a dynamic game. Alliances go head-to-head with gracious professionalism in competition. This creates a fun environment where students drive the engagement of their own learning, developing skills along with 21st century, developing technical skills along with 21st century skills such as teamwork, communication, problem solving, public speaking, and fundraising. Now, there are many team roles. That can prepare students for careers, being a team captain, programming, build on the build team, design, and business and marketing. These are all things used in FTC. Now I'm going to talk to you a little bit about the actual gameplay of the typical FIRST Tech Challenge game and how it's different from other robotic competitions. Now, robots in FTC must fit into an 18 by 18 inch cube at the start of the match. We play on a 12 by 12 foot playing field with 4 robots, and you will either be on a red or blue alliance with 1 allied team. The initial set of competitions are completely random, so your partner in one match might be your opponent in the next. After all the qualification matches, the top 4 teams will pick an alliance partner and go head to head and see which team is best. The winning alliance counts and then gets to move on to the next competition. Now, the autonomous period. First 30 seconds of the match is the pre-programmed autonomous period, which is up to you to make your robot move all on its own. This can be accomplished through several methods, such as drive-by time, light sensors, or encoders. There are images on the field for the robot to orient itself if you choose to use vision sensors. The next minute and 30 is the driver controlled period. Team members can drive their robot around the field, completing tasks using game controllers. And the final 30 seconds is endgame, and robots can continue doing the same tasks or attempt one of the endgame tasks, which are usually more difficult, but they will earn you more points. All right. And here's some examples of some kit materials you could use to build your robot. So you have a Tetrix, a Rev, or you could design your own. You can use custom pieces, or you could buy other materials to use. There are some specifications for what is and what is not allowed, and it's usually stated in that year's game manual. For instance, one year our robot had sandpaper on it as part of the thing, and that was not allowed, and we had to take it off that competition. That was a little wrench in our plan. So here's a little bit about the technology that you're going to use on your robot. Here we have on the right our Rev pack. So you have our battery pack over there, which is what we use to power the robot itself. There's its charging cable. And the control hub is what all your motors plug into, and then that will plug into something else. I'm not too certain. But that thing will communicate with your phone or expansion hub, I believe I don't know what it's called. Rev, either way, it communicates with that machine, and that's what will have your code loaded on it and what is connected to your game controllers, and that's how you control your robot. Here we have an example of an autonomous code visualizing a game piece. So that's how that would work. Yeah. Now, the development of programming skills progress through the level of leagues, and although FTC allows many programming languages, you start here with the basics at the first Lego League, primarily drag and drop blocks, and then once you get to the first check challenge, you can still use a lot of blocks apps, but you will also use more coding, written code options, and then FIRST Robotics. And too much about coding. Now to the next part. FTC teams typically use one of 3 programming languages. Blocks, Java, or Android Studio. Blocks is graphical, and Java is text-based, and both are done on the phone. Now, Android Studio is another option of written code, and that is done on a computer. There are a lot of tutorials for this on YouTube, and that is actually how every programmer I've ever known has learned. Yeah. Now, even if you don't go far in the robotics aspect during competition, there is always hope in judging. There are many prestigious awards to win, and even one that can get you to the next competition. Teams give a presentation about themselves and their accomplishments, and teams document their season in an engineering notebook that the judges will use to determine your standing. Now, I'm going to tell you about team startup and registration information. Now, here's the season timeline. We have our kickoff on September 10th, and we will be hosting kickoff events here in Albuquerque at the Lade School and in Alamogordo. That location is to be determined. We will be hosting competitions in Albuquerque, Alamogordo, and Socorro throughout the season. And here's our commitment and pricing. The in-state competition fee is going to be $150, and this will cover all qualifiers, scrimmages, and the New Mexico State Championship. This is different from previous years where you would cover each of these costs as you chose to do them. The rookie grant opportunity is also available for a team starting out, and you are eligible to receive $750 for startup. Now, there is a First Tech Challenge curriculum and class path made especially for schools. This serves 24 students from 7th through 12th grade. And now, if you're interested, these links are available on pamphlets. They're up here with QR codes and every other information you possibly want. I also wanted to briefly say why I chose FIRST and not some other robotics league. I know you've heard the words gracious professionals and cooperation thrown around all day here. And what that basically means, the gist of that is a good sportsmanship and basically competing to the best of all our abilities. An example I always like to use. When I first got there to my first competition, I was blown away at how you could go there. There were teams that went and their robot was broken. You know, things just happen. Oftentimes, you've never run your robot with a bunch of other robots. You know, it's a lot of there's new waves going around, they break down. And teams will go and it'll be completely broken. Their code's a mess and their robot's falling apart. It just happens. And there will be teams all over the room, and they'll try and help them. They'll, oh, can I help you with this? Oh, what code do you use? Oh, I know that code, I can help you. It's just a really nice community, and I really enjoyed how everyone was so helpful. Everyone just wanted to be able to compete the best we could, and I really appreciated that myself. Yeah. So, it's not about the robots. It's never been about the robots. It's about the kids. It's about the community. You know, and there's something that Dean Kamen did say at the competition is that it's not really about, you know, I'm not about the robots, but anyone can do this program and go pro in something. It's about building up the person, and I really like that. Anyone have any questions or anything I can expand upon?
Great, thanks, Madeline. Really appreciate that. Are there any questions about anything that we've gone over this morning? We thought next we would, if you'd like, we would demo a little bit our robots here for folks that are here and can show you that. But I just wanted to see if there's any questions or things from folks online. Yes, we will. I will definitely send out both presentations and the recordings after this. So that'll have the links in it. So that's a great question. Thanks, Ashley, for that question in the chat. Are there any other questions? You can pop them into the chat. You want to go ahead and enable the robot okay, so we're going to do a little bit of a demonstration. So we're going to Clark's going to take this and be the cameraman. Yeah.
It is. Geeks like us, we can pick on the other people,
Okay. That's kind of our demonstration for today. Looks like something disconnected on the robot. So thank you all very much for your time and attention today. And I'm going to go ahead and close out. And please, feel free to contact us or with any questions or need for information. So thank you very much.